on. I want to raise two things. First one, I'll just share a screen, which is this one. So you should have FISCON 2024 showing up. This is the annual physics conference taking place in Melbourne. It's on the 23rd of February next year, and it takes place at Swinburne. So that's for Tom. Well, for others, Interstate Swinburne is a university, but it specializes particularly in astronomy. It's a very strong astronomy and radio astronomy center. So the physics conference is run by Vic Physics. It's a load of volunteers, ex-physics teachers or current physics teachers like me. And I gave a paper at this conference last year, same conference, on astronomy during the school day. So that was general astronomy. That was things like solar observation, meteors and things like that, anything that we can do during the school day. And that's a lot of that was what got me onto the radio astronomy side. So this year I'm going to present a paper on radio astronomy in schools. And looking at the program, well, here's the program. I think mine is way down. Well, I'm in here somewhere. There. Oh, yeah, there we are. So there are all the presenters, including me. But the program here, this is the abstract for it. So the idea is to sort of go a quick whiz through. It's only about just under an hour for this paper, but it's a quick whiz through of what can be done in the name of radio astronomy without spending too much money. Schools don't have a lot of money. So I'm going to focus on the activities of the Astronomical Society of Victoria in the first instance, and also the activities of SARA, so that people are aware of what's available, and also the fact that there are some grants available. You would have seen that in the newsletter every month, that there are grants available. The society is, it gets money in and then is able to disperse that money to needy causes. So I'm going to raise awareness of that, of the two organizations. I'll just let Joe in, but I'll stop the share and wait while Joe joins us. Just connecting. Okay, Joe, you with us?
Yep, I am, yep.
Yep, very good. I'm just talking about this physics conference, FISCON, in February of next year. So really, I'm raising it here so that if anyone has any ideas of what I might include in a paper focused on radio astronomy in schools. So there are things like the Scope in a Box. I've got my own version of Scope in the Box, which, because they don't ship from America, I bought just through Amazon. I bought all the parts. So schools could certainly do that at a modest cost. There's Radio Jupiter, all the Jove stuff, which they could do. The Meteor stuff certainly is very affordable. You don't need anything fantastic to get radio reflections from meteors. So those are the sort of obvious ones, or even a transit of the sun. Just point an antenna at the sky and let the sun go by and pick that up. I think that's quite a doable one. And it may be that schools are prepared to share equipment or certainly share ideas. So that's the plan. If people have any ideas about what we could include, and interstate, those people interstate, if you've got schools that you know about that might be interested in pursuing this, they can come to the conference via Zoom, and the Zoom registration is quite modest. And then once you've registered for Zoom access, you get access to the recordings as well later. So if you've got schools in your area, or you know through contacts schools that might be interested, if you could alert them to that. So it's called FISCON, and it's in February of next year. And just while my second point is again putting out some feelers to see what interest there is out there, and I'm looking for astronomical societies around Australia. So now we've got Drake's Lounge Australia going, and we've got representation from a number of states. I want to try and, there's Michael arriving, I want to try and spread the word a little bit that this exists, and try and get some more societies involved. This is some American friends coming in, so I'll just wait while they arrive. Michael, I can see you there. Oh no, he's gone again. Oh yes, there you are. Yep, welcome.
Thank you very much.
So
thanks, Roger.
That was Roger, I think, that put you onto this. Is that right?
Yes.
Yeah, how are you, Michael?
I'm well,
I'd like to
thank you.
introduce Michael Samirsky. He's one of our members in the Astronomical Society here, keen to do some radio stuff.
Excellent.
We got together last week and had barbecues and looked at the whole thing.
Excellent. Well, and that, Roger, that's exactly what I'm talking about. So I'll just backtrack slightly. I thought, yeah, Alex, I can see. Hi, Alex. I think we had a time zone issue. But anyway, you're with us now. And I've got Butts NA. I'm not quite sure who that is. Is that who's hiding behind there? Butts NA for iPhone? Is that someone? Not able to speak, driving home. All right. So we've got you. You can hear us. And oh, Nathan. Yep. Thanks, Nathan. Once you're out of the car, we can have a chat. So just backtracking, I'm looking for expanding the reach of Drake's Lounge Australia across the states we've already got represented, and into the other states as well. I know we've got time zone issues particularly if we go to Western Australia. Now, through the Bintel shop, the Binoculars and Telescope shop, they have got, I found on their website, a whole list of about, I don't know what, 30 or more astronomical societies all around the country. And what I plan to do is try and contact someone in each of those and make a contact, see if they've got a radio astronomy group going, or if they're interested in pursuing the idea of a radio astronomy group. And then we'll just basically get more people coming along to the Drake's Lounge Australia. So again, if anyone's got contacts in either within your own society, within your own state, or if you know of other societies, please let me know, and I'll do some legwork at this end to try and get some contacts. So Michael, you're an example of that, where one person joining this group puts the word out and someone else joins us, so that's good. So any thoughts on those two things? The conference coming up in February, any ideas about what I might include in a paper which is aimed at radio astronomy in schools? And then any thoughts about extending to other societies. Do you have any contacts in other societies or in other states? I'll hand it over to you for comments. No, no one. John? No?
We've had a couple of things here. Actually, can you put a link on for your onto the chat for that site for the conference? Because I
That's
will
a
at
good
least
idea.
give it to the schools here.
Yep. I'll just do a copy paste on that. Copy. It's on the other screen, which is why I'm looking over there. Paste. And all right. So it's Vic Physics is the crowd organising it. You can see in the chat, and FISCON 2024 is the event, and it's
on the societies thing. Actually, Michael came up with another person here. I'll just see if I can get this to happen for Hawkesbury. So that fellow who came to the Astro Imaging, I would assume it was, meetings.
Yes, that's right.
So I've got he's got a website. I'll just see if I can find it.
He's been doing radio astronomy for 20 years, and he wants to get into astro imaging, and he joined our group, and I obviously had a great interest in his past.
Yes, Steve.
Yeah.
Oh, is that Steve Olney?
Yeah.
That's the guy, yeah.
Yeah. He's on my list.
Mm.
So
yeah, he's moving away a bit from radio work.
Yeah. Because he's the pulsar guy.
Yeah.
Yep. So yeah, I sent him out the reminder that you all got, although it was late. We all got here. There was a hiccup with that coming out. So basically, it's the fourth Saturday for us, the fourth Friday for the guys in the States.
I have a question about the physics for schools.
Yep.
Are you interested in teaching people about things like Doppler shift? Because satellites are really good for showing that, and they come around pretty often. And they're lots of power compared to radio astronomy.
Yes, it's. I mean, that's part of the whole thing. Yes, we would need to talk about Doppler shift. It's on the course. It's on the physics course. Particularly for the senior kids.
I'll try and I'll talk to you later then. I've got some stuff because I've been looking at SORAL and M2 satellites as they go past at about 600 kilometers, and it's quite instructive to see them move, not only in frequency but also their modulation sweeping across this as it changes.
Well, that's the advantage of an SDR, Duncan. You can actually see it on the screen. You can see the trace moving down.
Oh yeah, absolutely. It's real time. It's good to see it shift in frequency, and you can see the anomalies that turn up as well from other things, the terrestrial things in the band.
Yep. Well, that's a good point. It's I mean, we can teach the theory of Doppler shift. There's one we're doing in the lab with like an oscillator on the end of a bit of string, and you whiz it around, making sure it's tied on well, and you get the audio shift. Then you can do it with an SDR and satellites. That'll get you the radio frequency shift, and then that could be extended to Doppler shift with hydrogen line and all those sorts of things. So
it's a good lead in.
Yep. Yep.
The other one we have done in the past, a friend of mine did, was with a 1.8 meter dish, was showed and observing the sun, was actually to put an opaque material, radio opaque material in front of the feed and show that it actually cut off the signal and that sort of stuff. Very simple stuff, and also just attenuators like materials. That's what he did.
Yeah. Yeah, there's a lot of pretty straightforward stuff, and So, Alex, Scope in a Box. So this is for this physics conference. I don't know whether you were with us at that moment, but we can source the parts for Scope in a Box here through Amazon. And
did you see the info that I posted on the umbrella antenna?
I
Because
did.
that's even simpler. It works well. And it's super portable.
Yep. Yes,
Okay.
that's very much one. Yes, I want to include that. So the focus of the paper would be the activities of our Astronomical Society, because that's local, but also the SARA activities, Scope in a Box. But then your umbrella design is absolutely spot on. The key would be getting reflective material. I don't know what's the reflective material you use.
The students could build that. It's called, well, there's links on the video, but if you go to Amazon, it's called Faraday fabric. And it is it's like an electro-deposited nickel copper over fabric. And I mean, it's extremely conductive.
So Faraday paper, was it?
Faraday fabric.
Faraday fabric.
I had never heard of it before. The preppers and everyone that's paranoid about EMI have been using this for years. They put it on their walls, and they close out of it. But besides that, it is extremely effective, and evidently it is used like in military for instead of copper screening being expensive. This stuff is relatively inexpensive. Yeah. It is excellent.
Well, that could link then to what Duncan was saying about getting a signal and then blocking it, because you could put a piece of that in front and see that it absorbs it. The whole concept of a Faraday cage is a good one. Zero electric field inside a hollow conductor. That's on the course. That's on the course part we teach.
I think there's a deeper message in that, is that you can be inventive and take initiative with simple things to make things work. I mean, there's a difference between detection and doing some calibrated experiment, and this sort of innovation is really good in sparking people to think about how to fabricate something.
Yes.
Well, the Scope of the Box worked surprisingly well, more than not Scope in the Box, the umbrella, more than you might believe. It's like a 1 meter parabolic reflector is not particularly parabolic, but the feed is well tuned. In fact, I use that on my system, and the design, which I don't know, $100, $50, somewhere between that range for the umbrella and the feed, will give you about you get maybe over 1.2 dB from cold sky to the Cygnus area of the Milky Way. I mean, you get a nice signal. In fact, if you're interested, give me a couple seconds and I'll show you a slide on that.
I think it shows that, reflectors that are out of shape for a paraboloid by, probably 0.1 of a wavelength, 0.2 of wavelengths, still actually work pretty well. And just like book antennas and things like that.
Yeah, I'm just writing a few things down as we go along. So that's very good. And I think Richard just arrived. Is that Richard Blake? Not listening. Richard,
yes, it is. Yes, it is.
Yeah, thanks for joining us.
Did you see a couple slides of this umbrella? 3 or 4 slides?
Sorry, you're breaking up a bit, Alex. Do say again.
I said, did you want to see 3 or 4 slides on this umbrella?
Yeah.
All right.
Yeah, that'd be good.
Can you see that?
Yep, got it.
Oh,
All right.
Good one.
All right. Okay. Let me see if I can get access. So that's what it looks like. It's just a photo umbrella, but the Mylar material is not reflective at all. So this is lined with sheets of of that Faraday fabric. This is a nice tune feed, and it really is pretty efficient. That couples right into the Go Electric Sawbird. Oh, that's just a calibration cover, but that's what the signal looks like in real time. I mean, you can get a fairly decent response, and this is some data from that. 5-minute samples over a period of time. Pretty good noise ratio on that stuff, and I've written some software in MATLAB. That's the kind of that might do. So it is usable in that you can actually get some real calibrated data.
Yep.
Oh, good.
Yeah, now, Alex, are those slides on the SARA website somewhere?
Yes, if you look on their videos, there's a video on that. Let me see. I'll find it and put it in the link.
Yeah, because that would be ideal. That's something that people can do. You know, drop
I mean,
them. It's not an expensive
I mean,
exercise.
it could be a student project. It really,
Yeah.
it's that easy to build.
Yep.
And there's a follow-on from that. If you have a look at the antenna on Radio Astron, it's this unfolding petal type thing. So you can see the professionals that have actually used it for space radio astronomy work.
Very good. Just for Richard's benefit, Richard Flagg has joined us. Richard, we're talking about a physics conference that's coming up in February. I can share the screen again just to give you an idea. So I'm giving a paper at this conference in February on radio astronomy in schools. And I'll include in that Radio Jove, the whole story about Radio Jove. So that's one of the things that we'll have in there. Scope in a Box, certainly Alex's umbrella antenna, I think is a really good one. So we're just, Richard, we're just playing around with ideas about what we might include, what I might include in that paper, aiming at school students. Radio Jove is certainly spot on, I would say, for that paper.
Well, Paul, if I can give you any input on that, please let me know.
Yeah, that'd be great. It's really good having you with us, Richard, because you know you've got all those years of experience which we'd like to draw on. That's absolutely fantastic.
Be glad to help any way I can.
Yeah. And Alex as well. It's great to have Alex and all your experience with the stuff that you're doing. It's fantastic.
Okay, I just put that out there.
Yep, got that. Thank you. Right. So that's my two things. One is the physics conference in February. The other one is just getting the outreach going to other societies around Australia so that we can expand the scope of Drake's Lounge Australia. And that's my project. I've been doing extra teaching for the last few weeks, so I've been really out of the loop when it comes to a lot of this stuff. My exam is now written. All I have to do is mark it, and then that'll be the end of the school year. And then I might have a bit more time next year to pursue some of these things. So any ideas that you can feed in, please do so, and I'll incorporate them in. So
just before you go, may I share my screen with you to show you what a Doppler run looks like?
Yep, sounds good.
So this is a Doppler run on S2 with a helical antenna. You can see the Doppler shift on the bottom left trace as he came across the horizon, went up a bit and disappeared. So that's done on SDR.
Yeah, spot on.
Okay.
Over what time period was that, Duncan?
Most of these passes are 10 to 12 minutes.
Yep.
So it's pretty instant. I mean, you know, unless you're extremely bright satellite, you don't see them before they get over the horizon. There are, large transmitters up there that you can see over the horizon, but they come up, they're very obvious, they disappear.
Right.
And you can see all the modulation on that particular carrier there as they're, I think they're phase shifting.
It's of note. In the past, I've done getting signals from satellites. We were one of the early adopters of FunCube, for example. Some of you may be aware of FunCube. And we were one of the early ones on that. And then we've also been getting pictures from the International Space Station. And at the moment, there is for the next week or so, they're transmitting on a regular basis more slow scan television. And that would certainly show up the Doppler. But that's because it's FM. It's you can just stick it on a central frequency, and the FM discriminator, I think, follows it. So, but that's a really good one. If you're interested in signals from satellites, slow scan television is really good. And last year, while I was at the beach over summer, there was a visible pass of the International Space Station. There are apps that tell you for your location when it comes over. And it was like a 15-minute pass. It was really, really bright because of the particular angle of the sun. And at the time that it was going over, so we could see it visually, but I also had a handheld receiver, and I was picking up the signal from it on slow scan television. And then the audio from the receiver was going into my iPad, and the iPad was converting the audio into a slow scan television picture. And I'd have to say I was pretty impressed by that. The fact that I could see the space station and actually get signals from it and decode those signals in real time into a slow scan TV picture.
Did you say that it was visible for 15 minutes?
So it's of the order of, it may be 12 or something like that. When you get a good pass. If you get it was quite a high pass. If you get, like an 80-degree or a 75-degree pass, it's there for a long, long time. It's not like it's a sort of quick whiz by. And I've talked to people who are going by, here's this strange person standing on the beach with an iPad and a radio receiver. What's going on here? And I say, well, that's the International Space Station. Oh, and they sort of, can't believe this. And I said, well, there are people on there. There are people living on that space station, and they're sending these signals. How good is that? So I'm surprised there aren't more news reports about this bright light in the sky, because when you see it, it's really, really bright. But the trouble is, most people don't look up. They never look up into the sky. They too busy looking at their phones, I think. So we'll just do a quick whiz round. Duncan, do you have anything else to add from your point of view? And then I'll jump to perhaps Roger next.
Yeah, I do. I'll get rid of this first one, and I'll share a screen with you from results from a few days ago. Here's the Vela pulsar going through. This was done on a 2.3 meter dish, just a standard C-band satellite dish. Nothing particularly fancy on it, except the antennas probably is a little different. So it's done at 820 megahertz. It's a 1 hour integration, and you quite clearly see that we've got fairly good signal to noise. So actually do some timing on that one and look for a glitch. I was going to get the picture of the dish up, but it's on my phone. I haven't got it there. So that's what I've been doing, working on, as well as other little projects. Most of the gear on the dish is actually all second hand, or except for the SDR and the antenna. And I make my own LNAs. because I've done that for a long time. And we estimate the system temperature here is around 70 to 100 Kelvin. There's a fair bit of spill over the edge, but that's what you can do with a 2.3 meter, just sitting there watching. It's automatic in the sense that it's a transit instrument. The Raspberry Pi 4 is got a scheduling program on board with a bit of software, so it just sits there, and just every 24 hours it takes data and I process it afterwards. There was a major problem with this data. What I'm showing you here is 6 months of head scratching and final solution. I found the Pi 4 on a 32-bit operating system architecture would drop packets on the USB. In this game of this sort of pulsar work, dropping packets is a big no-no, because it would give you 2 or 3 spikes in 1 hour, because it drop at packets, and it's therefore not continuous data. That was resolved by moving from a 32-bit operating system to a 64-bit operating system. If anybody's interested in what I did, email me, and I can tell you how I got over the problem.
Great stuff, Duncan. Is that your personal setup, or is that a club setup?
No, it's my personal stuff. I have a range of antennas here. I have a 510 Helix for satellite work, which started out as a crazy project of started out with a front wheel bearing disc assembly from a Holden Astra as platform, and just evolved from there. It was actually a project just to build a radio telescope out of scrap and available stuff. I have 10 turn here, and that one's at about 500 megahertz for doing satellite work, and I'm going to try and just see if I can see other things with it. I certainly can see the galaxy go through. That's no problem. I've got a 300 megahertz 10 turn Helix and a 2.3 meter, and at the moment there's also a 6 meter on a pylon, but that's a work in progress at the moment. So that's the range of gear.
What's your location, Duncan? You must have lots of land.
Yeah, I sit in a wheat field. I'm a share farmer southeast of Adelaide on the Fleurier, and I should declare that I'm not an amateur in that sense. I've been doing radio astronomy for a long time. I started when I was about 14, and I've done it professionally for about 37 years now. So still like playing the game and pushing the envelope. So
yeah. Hence the results you've just showed is very, very good.
Thank you.
Yes.
So if people have questions, please ask. I'm happy to share my experience. So and I should say I was the officer in charge of the Molonglo Radio Observatory in eastern New South Wales for 29 years. So done a fair bit of work on transient phenomenon in the sky.
Great stuff. Yeah. Any questions for Duncan before we move on? No, everyone's happy. Well, just going around on my screen, Roger, you got anything you want to share?
Not particularly. I'm quite busy at the moment, unfortunately. It's a busy time of year for me. One of the things I'm doing is extending my workshop, which is probably where I'll start building radio telescopes at the moment, because I'm extending my existing workshop. Looks like a bomb's gone off in it. But anyway, my Super SIDS has arrived. I've got to admit I haven't even had a chance to have a look at it yet. And I probably won't for another month or two, I'd say. And I'll probably be an apology next month as well. I've had a short story published in the book of seniors short stories, and the book launch for it is on the Friday before the next meeting. So I dare say I'll be in Sydney, The book launch is actually at Parliament House. It's a government thing, so I'll be hobnobbing it with the Pollies. So I probably won't see you next month.
Yes.
But apart from that, I don't think much else has really happened here. I went out and looked at my dish the other day, and it's covered in bird poo. Now, it made me think about those couple of guys all those years ago that thought that radio astronomy was all about bird poo. So if anybody's interested, we could redo the experiment.
Yes. Well, Penzias and Wilson.
Yeah, I don't.
Yeah, that's right.
I think the optical depth will be a bit short.
Yeah, that's a great story, though.
Anyway, so no, not a lot more to go. As I say, I'm very busy. I'm also involved in the local theatre group, so we're putting on plays in another couple of weeks. So I'm just going to be flat out for a couple of months. But anyway, in the new year, I'll put all this stuff together and hopefully I'll have more for you.
Yeah, well, I know the feeling about being too busy. I just haven't had a chance to do anything. My garden is a mess at the moment.
Yeah, that's the other thing. Garden time of year too. Everything's starting to go mad.
That's right. As soon as you get some warmth and some rain.
Yeah.
The tomatoes are doing well, though. My tomato plants. I do hydroponic tomatoes. And,
that sounds good.
They're bloody fantastic. Very good. Thank you, Roger.
That's all right. Thank you.
On my screen, Rob Lucas. Have you got anything you want to tell us about?
Hello, everybody. About a month ago, I sent a bunch of scans to, Ted Klein, and I haven't heard back with what he's done with those. I have my version of a scope in the box. I'm assuming you can hear me.
Yes,
okay.
We can. Yep.
Okay. So about a month ago, I jumped on the airplane, and I don't know why people, anyway, it's Friday afternoon for me, and I'm sitting here, at my computer in San Francisco, and I look out the window of my bedroom, and I can see the airplanes take off and land at the airport. Okay, now the reason for my trip is, let me see if I can, share my screen.
Yep, should be able to.
Okay, I click the button. What happened?
Nothing.
What do I need to do?
I think
You have to click the screen to share. Click on what you want to share.
Yeah, the green.
I see a green share screen.
Yeah,
I
click
clicked on that,
and then it should give you the options of which things to share.
Okay, I'll try my desktop.
Yeah, just share the desktop.
Nothing happened. Whiteboard, phone, folder, GoPro. Wow.
Should give you a screen view, and you just click on the screen you want.
I don't see anything coming up.
Right.
Yeah.
I'm not sure.
Can you see that?
No, nothing's coming up, Rob.
Oh, that's no fun. I don't know.
I do the green button. Yeah, I get a window with all sort of options, whiteboard and iPhone and all sorts of things.
Let's try this one more time. I've got a desktop, whiteboard, iPhone.
Do the desktop. Just click on the desktop. No.
Allow Zoom. Okay, I can do that.
You have to have open what you want to share, Rob. Have you got that open on the desktop?
I can see it. I can see it on my screen.
Is there a share on that actual window on the right-hand side? Down the right-hand corner? Bottom corner?
I don't see it.
Have you got the file open that you want to share?
Yes.
Yeah.
See, I can show you. Can you see this? Can you see that?
Yep. Looks like an eclipse.
Well, that's what it is. Yeah, I'll just hold the camera up at it.
Yep.
What I did was about 6-7 months ago, I thought I would go to the Rainbow Bridge at Monument Valley, and I find out at the last minute that there wasn't enough water for me to do that, and I didn't have time. So what I can do is, with luck, this will. what you can see here, you can see start to see the Bailey's beads showing up.
Yep.
And I pointed the camera at the wrong thing. You can see them all up there. Way cool.
Very good.
Oh, that was the total. And going through all of this stuff. And what I did, I got greedy. So what I tried to do is, that's close to the black drop effect. And you can see, the black drop effect of the
Yep.
Bailey's beads through there.
Very good. I think there's
Okay,
another one coming up soon, isn't there? Another,
the April 14th next year.
and that's when the Western Conference is on, if I'm right, I think.
I haven't checked on that.
That's
what
what they
else?
say, right on that
Hi, Ted.
same day. Rob, I'm sorry, I need to get back to you on those things.
That not a problem. I'm still in San Francisco. I've got another week to go before I head back. And I've got the observatory at Waruna. I've got the hatch opening and closing, and I've got the floor in. I've got a telescope in the dome. And as soon as I did that, I got on the plane and I flew to San Francisco. And to get to where I took the images of the eclipse, I flew from San Francisco to Las Vegas, and I drove across Nevada. Now you can't tell anybody I did this, but it was like 160 kilometers per hour going across Nevada. Everybody was doing 90 miles an hour. And going, well, what the heck? We had a good time doing that. And I went to Lake Powell. Stayed at the Hilton there, and we got up early on the day, and we drove over to 25 miles south of the entrance to Monument Valley, and I set up in a rest area, and I've got a GoPro movie of it, and you can see the change in the intensity of the sun. It went from really bright, to kind of dark at the area. I've got my GoPro video of that, and I've got a bunch of single images of the partial eclipses. Is my voice breaking up? I can hear it in the back of my headphone.
It's all fine. There's some crackling going on in the background.
Yeah, I don't know where that's coming from. I don't think it's me.
Yeah, not quite
Could
sure.
be.
Yeah,
It doesn't matter. But anyway, so the observatory is done. Since I sent the scans off to Ted, I've started studying how to how to expand my single scope in a box to 2, possibly 3, to make an interferometer, and I'm learning how to mix the signals together and what to do with that. I'm hoping to make it down to Stanford, to the solar research area there next week. It's only 10 minutes down the road from where I'm at. But I don't know anybody there, and I'm not sure what I can do there. Normally I know people at the observatories, and I, give a call, and and I go down there and talk to them. I've been to the solar observatory at, down by Riverside, and we did a transit of Mercury for that one. That was good fun. I've been to the solar observatory at, Sunspot, New Mexico. Done that. I've been to the radio telescope at Socorro, the Jansky, and they actually let us out there to, image an annular solar eclipse for that one too. So anyway, and Paul, do you think, they want to go into university studies for radio astronomy?
The school students, you mean, going on to university?
No, I mean, for your presentation, because the SKA people, Tara Murphy at the University of Sydney, she's one of the directors of that, I believe. I can always ask her to, possibly contribute to your presentation.
Well, certainly ideas. I mean, the target audience for that conference is school students and school teacher. It's a school teachers conference,
right?
But input from anybody really is valuable. Just ideas I can incorporate.
Yeah, I got the impression you were, looking at high school students more than university students.
Yep.
Yeah.
But contacts are always good because
Yes.
there's a lot of remote stuff now we can get into as well. So I mean that's essentially at zero cost to schools. They can remote access a whole variety of different things. So the more contacts we have, the better, Rob. That'd be good.
Yeah. I'm tempted. I haven't talked to Ted about this yet, but I'm on top of the hill here at Belmont, California, and I'm thinking of setting up a radio, like a scope in a box here, and seeing if I could link it with my scope in a box in Sydney. I don't know if that's really possible, but it sounds interesting. Do the digital,
You're getting a thumbs up from Ted, Rob, on that one.
Oh, I saw that. Yep.
Yeah, I think the issue would be getting the timing right. That's going to be the key one on that. But
yeah, that usually is a great problem, getting it synced and maintaining the sync.
Sync is the issue, but I'm sure you can surmount all those problems.
Yeah.
Very good. Sounds like you've had a busy time, Rob.
Okay, and we'll be back in 2 weeks.
Yep. Very good.
Rob, you probably, if you try and do that thing, you need to have a good time source. And I mean, I'm not talking about a crystal. I'm talking about a real clock.
It's got to be GPS, I think, isn't it?
You can use the GPS and take the 1 second pulse from that and use that to synchronize.
Really tough timing. It can be very difficult to do.
Yeah. There's a whole lot of things that mitigate against that. It's the transit times through the network, but also ionospherics and maintaining time sync. So you need probably need something that gives you hydrogen standard frequency stability because it's such a long baseline.
Yep.
It's well.
I'm sure it's possible.
It's doable. We'll be following that one closely, Rob. See how it goes.
Okay.
All right. I might go to Michael next because you're next on my screen, and you joined us first time this time. What are you doing, and what can you share?
For years, I wanted to get the radio telescope at Ilford at the ASNSW club working again because someone was threatening to dismantle it as well. So I bought a Hack RF1, did some research, got all excited, then life got in the way. So 5 years later, I've retired, and I hope to be a little more active and proactive on getting this working. I don't know if you guys have seen a picture of the scope. Roger, what is the diameter of that thing? Is it about 4 or 5 meters?
It's 18 feet. So it goes back to the old. It's an imperial era thing. So yeah, 18 feet. And I think the focal length on it's about 6 foot. So what's that make it? About a 0.3 or something? Seems to be reasonably standard for a satellite dish type of F number. So anyway, 18 feet. I measured at that. So reasonable size.
And this thing was originally, I don't know, manufactured by CSIRO, but it was part of a 64 by 60 or 64 element or node. I don't know what the right terminology is. Cross configuration. So out at near Badgerys Creek, Kemps Creek. And if you look on Google Maps, it's very interesting. Sorry, Roger, what did you say? Your mic was off.
That's Fleurs was where it was.
That's the one, yeah. So if you look on Google Earth, you can see some old collapsed ones there. And I've also found a video by CSIRO from 1950-something that shows it actually, the array of them working. And it's quite nice to see how the mechanics worked and how the mechanics that we have at the club there is slightly modified. Anyway, it was all rusted to buggery, and using some WD-40 and a wire brush, I was able to get the thing to run so smoothly. And now I've stuck a whole lot of lithium grease on the gear teeth, and it's as smooth as, even if you leave it in the weather for a year, you can still spin the thing with one finger. It's beautiful. Anyway, I'm looking at building a motor drive for both axes and using a Raspberry Pi and H-Bridge to drive those motors, provide an Indie interface to it. And if people don't know what Indie is, if you know what ASCOM is, which is...
Oh, Indie.
Yeah, Indie is a more open source version of that. And if I can do that, I can then steer it via the internet remotely by providing a web interface to the motor drives. And that's my first step one project in my mind. And I want to be able to build a little a chassis that I can bolt on to the existing back of the gearing on the telescope, hook a belt drive up to whatever currently can turn. It's that way I'm not impacting or modifying the current equipment, to sort of preserve its history. So I don't want to ruin it while I'm doing this. At most I'll probably drill a few holes onto it with an out to put my aluminium frame, which houses the Raspberry Pi and the motor drives. And then I can, I'm going to be like 5 hours drive from that damn thing when I move. So I can build that at home and then bolt it on and experiment with it and just remove it easily without impacting it. So that's the motor drive side. This is all, just dreams that I want to complete. That I want to make I don't know what the right terminology. So the radio astronomy side of it, even though I'm an electrical engineer, I never did much communications. I did a lot of mechanical and computer stuff. So it turns out that the tin from Aldi that they sell lentils in once in a while happens to be the right diameter for 21 centimeters, and it looks as though all I need to do is put I don't know what the right name is. If this is the cylinder, poke this little antenna element into it, and I've almost got the right dimensions to just hook that straight up to the Hack RF1, and using Linux, or I'm sure you guys have been playing with this stuff for the whole time, Windows, Linux, whatever, just see what I can pick up on the Hydrogen Alpha line. And if I were to be able to scan the sky using the motor drives and be able to generate the Doppler image of the galaxy, would be step 2. And by then I would be happy if I could get that far.
You're in the right place, Michael, because you've got a lot of expertise.
Yeah. Well,
in these various windows that you're looking at.
Yes. So anyway, do people think that's achievable over time?
Yes.
That's good to hear.
Also, IKEA is good for having a look around for various pots and pans that may be useful.
To build what aspect?
It depends which frequency you're using, but I use IKEA cake tins for my weather shields and my RF shields because they're spun and I can then cobble them together in the right size for what I was doing. So it's rather than buying a box, you buy something that's continuous and low cost.
Are you talking about making a small version of the whole thing at home as a prototype, or
no? I'm talking about.
Sorry,
I was talking about your circular waveguide and.
Gotcha. Sorry. Yes.
There's lots of spun material these days that if you source it, it's cheap and of the right sort of size.
And the antenna had a central. I don't know the terminology. The dish had a central antenna, and I was thinking, well, I didn't know much about how that thing worked. Roger does. I was thinking of putting some PVC piping from the rim of the dish to make a central thing to put my receiver in that way. And of course, I could always screw it and unscrew it without damaging the original hardware. But PVC, I thought, would be the way to go for transparency. Not the case.
I've just done that to my 2.3 meter and I just lost some forward gain. Now I can't work out whether I got off focus or not, or I've created some other problem. So I'll let you know in a month or two.
But PVC should be transparent, right?
It's relatively transparent.
Yeah. I know there's some dielectric constants or whatever that makes it not quite that.
Yeah,
but it's better than metal, right?
It's different.
Yeah. Okay.
It's an absorber, and it absorbs the free, and it sits at 300 Kelvin, and that's it. And so but it's what its optical depth is, how much it's radiating and how much it's absorbing, and it's a very small fraction of the actual aperture.
Mm-hmm.
Whereas the metal's a scatterer, depending on its
I
size.
see.
It's something I'm still coming to terms with about what the model. There are models around, and there that allow you to model the dish. I think there's a student version of a thing called GRASP, which allows you to model parabolic antennas, and yours is what they call a prime focus feed, I believe.
Right.
There are other types which have a hyperbolic mirror, but you really got to go as a secondary, which are called Cassegrain, which you actually put your receiver at the vertex of the paraboloid.
Okay.
Just behind my ear is the antenna that's worked out so nice for me. I really enjoy having a central stick right up the focus, that red stick over my ear. And then you can adjust the distance to the dish so much more easily, as opposed to 3 sticks up there that you have to adjust and try to find the focus and all this kind of stuff. I figure if I've got the central spot, I can just slide up and down that red stick. I'm thinking PVC would work out fine.
Yeah, there's on a larger system, you have to watch the mechanical vibration. You've got have a mass on the end of a PVC pole, and it tends to move around. If you have a rigid tie down point, you can actually tie it to the circumference of the dish, but you can get oscillations in it.
I've just shared a picture of the thing, of the scope itself. People haven't seen it.
It hasn't come through.
Oh,
okay, yep.
Yeah.
It's on the chat, I think.
It's on the chat, yes.
It's oh yeah, there it is.
Yeah, I think that's 21 centimeter. It wasn't the big dishes that were Fleur's. Fleur's has a rich history of using dishes as cross formation. As low as, I think there was one called the Shane Cross, and another one as far down as 18 megahertz in the early days. And if I remember correctly, this one actually had one of them had a long set of connected rods that actually changed the right ascension axis, I think, on it. Slewed it round. Anyway, enough of me.
Yeah, it did. It had a you can see it's got the counterweight on there, and it had an arrangement with a pole system that actually just moved it a little bit to keep it onto the satellite itself. So we still do have the central post in the middle of it. The fly wire on it is pretty bad, but yeah, basically it does go. So I think it's actually the central post on it is set up for 2 frequencies, and I seem to think that the original post is quite an interesting setup actually, because it's got a couple of receiver elements at the focal point, which then retransmits down a waveguide. So the actual central post is in effect a waveguide, and it's got a plug in the bottom of it as a receiver. So that was the first one, which I reckon was set up probably around 400 megahertz from the size of it, and then it's actually got a another feed attached to the side of it, which I'm pretty sure is probably 1420, and it's actually then run by a bit of coax, which is literally cable tied to the waveguide down to the bottom. So it's actually set up for two different frequencies, and the second one has obviously been retrofitted because it's relatively rough compared to the really nice manufacture of the original one that just feeds into the waveguide. So yeah, an interesting setup. I've never seen that before. Everything that we've always done actually feeds power out to a receiver, and all that power stuff happens there. This just receives the signal, sends it down a waveguide, and had the receivers in the bottom of the dish.
Yeah,
So,
you have to.
quite interesting.
You have to. Their philosophy was quite different in those days because their system temperatures were huge, and the engineers that put this together, or engineering physicists, that I'd like to say, were just a class in their own, above a lot of the engineering. So Fleurs was running Electrical Engineering Sydney, and there should be a heap of papers around telling you what they did, but I'm not sure if this is the one where they did synthesis work before synthesis got really popular.
Rog, there's another picture if you just want to share that of us having the barbecue underneath for scale.
It was a good day.
It was a great day.
One of our members, his wife is Brazilian, so we had a Brazilian barbecue, rotisserie over charcoal. It was interesting.
Can you open the picture up to share?
It's still coming in.
Sorry, right.
I'll grab it in a moment.
He's slow.
I like the pictures, but I'm scared about that table you have it set on. Seems like a big structure for a little shoulder. Good luck.
It certainly shows the rust coating on it.
Yeah, I've got tons more pictures of all the mechanics around the back. You can just see that semicircular gearing. Yeah, up where your mouse is there, Rog. If you just want, I've got tons of pictures of that. If I can upload them somewhere, and also I'll send the video of. Rog, can you put your pointer on the little driven wheel there? Sorry, with the little handle on it and the teeth.
Yeah, that's the thing with the little spikes on the side were operated by that piece there.
Yeah, I can send a video to show how that works.
Well, there was a shaft going underneath the whole, each one of the line of them, and on that shaft there was another piece coming up that just knocked that. It just would go from side to side, and it would just turn that one click every time it went past. It was quite quite ingenious way to do it.
Simple and ingenious, yes.
Yeah, it's the right actual. It's driving the right ascension axis. Yeah, they were very clever.
You've got your cans of WD-40 there as well.
Yeah, lithium grease and just regular lubricant from Super Cheap Auto.
Very good.
Yeah, the Aerostart won't work on it. Sorry.
So where could I upload pictures and a video link offline?
It was dinner. That was lunch, including beer.
Yeah.
There's got to be beer.
So you can see our other problems with it is the if you actually zoom in on the mesh, Michael, the mesh has got lots of holes in it. It's actually made the mesh has been done with Avery mesh, about a 1/2-inch square Avery mesh, and it's very deteriorated. Some of the poles on the side here are bent, so it's not perfectly aligned as parabolically. So we have issues to do, and I'm not quite sure how to replace the mesh on it at the moment. I've got some Avery mesh, but I think we need a dressmaker to actually put it all together.
I think you probably just need to make the inverse of it and then lay it on that, and but a bit 1/10 of a wave will be adequate.
Yeah, okay.
So you don't have to have the perfect parabolic shape. You can have it in sections.
Okay.
Sounds like you've got some work ahead of you, Michael.
Yeah. Well, I've got time ahead of me too.
Yeah, excellent. This is what we want.
Yeah.
Hydraulic bender.
just watching the time. So are we ready to? We'll move on. John, is there anything you want to share with us, John De Kaiser?
No, I haven't got anything to share at there, Paul. I'll just yeah.
Okay, no problem.
I'm a listener at the moment.
Excellent, good. Joe, you've got anything there?
Guys, I'm going to have to leave.
Yeah.
So
okay,
I'll catch you next time. Thanks so much for the invite. It was great.
Yep.
See you all. Bye.
Always
Hey,
well.
Michael.
Sorry, Joe.
That's okay. I'm a bit like John. I got nothing at the moment. I've been busy with other stuff. I have a dish out there. I have the 3/4 built, the receiver. I've got to put the whole thing together, and then I can maybe start doing something. But I do need to get some time to be able to do that. At the moment, that's not happening. I'm busy filming, so I'm doing a lot of video work. So that's me for this month. Also, I'm afraid. Thank you for the meeting. It's been good.
Very good. Just on the Astronomical Society of Victoria dish, talking of that, some of you would have seen the refabrication of the worm screw and so on. That's all progressing, and there's a meeting up at the site there on the 25th of November, I think it is. So there'll be some progress there, and that will be back operating. And then the longer term plan is to remote control that one as well. So lots to do. I think, is that all the Australian?
Paul, they're actually working on the horn antenna too, so that's going to be another thing.
Yes.
I had that on the hydrogen line as well, so that's going to be good as well. So,
yeah.
Presumably looking at the galactic plane, I'd say, of scan drift.
Yeah.
A drift scan, yeah.
Yep. Yes, so the horn is operating. They'll keep improving that. So we might go around the US contingent, starting with. I'll start with Richard. Richard, have you got anything you want to share with us?
Not really, Paul. Just enjoying listening to all the good work you guys are doing down there.
Yep, excellent. Certainly plenty going on, plenty to think about. Alex, I think you're next on my screen.
I don't have much. I wanted to share one other picture of that umbrella antenna and show you the simplicity of the feed. One thing I missed before. Let's see. Okay, so you see the umbrella antenna. The one thing that I didn't show last time, well, is that. And I mean, this is a nice tune, full wavelength loop antenna, loop feed, and it's actually efficient in that the LNA is coupled directly. Is actually attached to say diameter cake pan, and I use SMA right. So it's very simple thing, and it's efficient.
Your audio is breaking up a bit, Alex. I don't know. What have you got?
Don't know. Is it still working?
Yeah, that's better now. You've done something.
Through my internet. All I was going to say is that it's a simple design, but it's pretty efficient.
Yes, I've seen the discussion about cutting cake tins as well. That was quite a challenge.
Well, this is no cutting.
No cutting on this one. Yep.
This is a 6-inch, 2-inch depth cake pan.
Yep.
So 2 holes, 1/4 inch and 1/2 inch hole, and this slides over the stem of the umbrella antenna. So this is complex. You can make it out of a piece of lucite or something tubing. So
very good. Yeah.
So anyhow, that's all I had to add.
That's a nice piece of engineering. That's really good. Thanks, Alex. Ted, you got anything from your end?
I keep playing around with 3 antennas now, and I get all kinds of strange shapes. I may have showed this last time. I can't recall. Something's going on here. We see all kinds of interference. 2 antennas would give a bunch of peaks. Let's see. No, but when you put 3 together, oh my gosh, it gets more complicated. And so I'm trying to explore that. If I slightly move one, is there some way I can get a peak in the middle and not others when I do a drift scan of the sun here? And that would be nice, because then in theory I am have an antenna made, an antenna array with a smaller beam width, the cheap way instead of a big dish. So I'm exploring that kind of stuff. That's about it.
I think it's a phasing issue. Is that right? We've got to get the phasing right.
Exactly. And I am being very crude and just combining the center conductors of the coax and let them fight it out and just add them together.
So this is
adding interferometer.
So yeah, so it's a total power adding interferometer.
Exactly.
Yeah, well, what you're beginning to, you will get, depending how many bright sources and very bright sources you get, you will get beating between the sources, because your primary beam is still that of your single dish. So you will get more than one source in the beam, and they can beat together, and you will get different. I don't know what the relationship is in the spacing of your antennas. So
I have so many experiments, I have to look it up.
Yeah,
but, 2 meters and maybe, I don't know, 4 meters, something like that.
Or you transform it and see what happens. Get rid of it.
Exactly. I'm just playing around at this point. I'm not sure it's really worth the effort. I will try to make an even simpler antenna that's maybe smaller and won't blow around and vary in the wind. Anyway, those are the experiments I'm playing with. The last couple of videos posted to Sarah talk about it too.
Yeah, it's one of these, what is known in this trade is confusion, having multiple sources in the beam at once.
Yeah, exactly. Although this is the sun, so I'm not sure that applies for this particular trace.
Yeah, well, yeah. You won't. Well, you won't be. Will you be resolving components on the sun? I don't know what your baseline is.
Resolving. I should get what I'm looking for is one big spike in the middle and maybe some lower ones to show those side lobes.
Yeah. Okay. Well, I have a different experience, but we used to get into trouble because the sun would be 1/2 degree and the beam would be 1 degree, and then you're tracking the sun, you're thinking it's a certain point, but you'd have a sunspot which was bright, and that would cause trouble in the experiment.
My antennas start at 30 degrees, so I don't have
okay.
that particular problem.
Very good. It's like some Fourier.
Oh, and timing. But timing, let's see, I showed up at 2300 UTC, but you guys have a time zone difference for a couple of weeks. Is that right?
We're on summertime.
Yeah, there's our problem. Okay.
Yep. So October through to the end of March. That was the timing difference. Now moving, where are we up to? Don, are you there, and have you got anything you want to share? No.
I am here. Nothing in particular.
Okay. And Kim, I can see there. Is there anything from your end?
Greetings from the north, and we too missed out on the time change. Their change of start here. Nothing new in the radio world at our end, and we just love hearing from you guys down under.
Yep. Well, you're always very welcome. I think we'll sort out the time change for next time. We had the issue of the reminder not coming around at this end as well for some strange reason. So, and we've got a couple of technical issues to sort out. I think, is that everyone? I think we've been right around. Richard's not back, so anything else that anybody wants to chip in at this stage? Might call it quits.
Paul, just an added issue. They're working on the eCallisto at LMRO with a new controller. I think Tim is working on that one. So that's going to be an improvement on the eCallisto, which is monitoring the sun, of course, and tracking the sun.
Yeah, I think they're trying to change the tracking. At the moment, it sort of sits there for a while, and then it does a jump, and then it does a jump.
Yeah. So this is going to be a lot better tracking system. So, so that's going to be a plus, I think.
Yeah. I think the issue also up there is the computers producing RFI, and they're looking at ways of isolating, putting all the computers in a box, basically Faraday them away, and then somehow getting signals in and out of that box.
Yeah.
So that all the timing stuff doesn't come out and get in the way of the signals we actually want. And I don't know whether I've suggested optical coupling. I don't know whether that's feasible. Whether we don't run any wires out of the box, we just run fiber.
Yeah, fiber's where you can do that. I've run USB to fiber, and done that work professionally. So you can do that. I'd say a container, and you go in at one point on the container, and no aperture. Say anything larger than a quarter of a wave of the highest frequency you use.
Yeah, I think they're talking about putting another container in.
Yeah, you can put pipe in and use a waveguide beyond cutoff, so you can put all your fiber through it, and then you make quite a long thing, and therefore any RF inside the box will not go along that waveguide. But don't allow anybody to put a coaxial cable in just for a nice short experiment, because that's a fast way to couple everything inside, outside.
Yes, and I think that's what they've found, is there are some coaxial cables that have been put in for, let's see what happens, and it mucks the whole thing up.
Yeah, the Cambridge telescope, I think the 6 Mile at Cambridge, they routed everything through one huge panel. All the coaxial connectors went through that panel, and I think they were worried about ground loops and pickup, and everything else floated. So it was a huge engineering effort. But grounding's really a big issue.
Yes. And the ground loops are an issue as well, I believe.
Yeah. So RFI is pretty insidious, and correlation's probably a good way to go and sniff it out. Rather have a reference antenna, and there are methods of using that for other sorts of RFI suppression by having a reference antenna that looks around your site, and then using a bit of GPU power, you can actually null out and look for the sky signal.
Yeah.
But it gets complicated, and my estimate professionally is that it's probably as complicated as building the instrument.
Yes.
It's a serious problem.
Yes. And of course, more time goes by at our Deep Sky site, the more electronics arrives in one form or another. So
I did an experiment one day to look at how a mesh was transmitting, how much signal was come through a mesh from a transmitter in the far field. And I clicked the camera to take a picture of the spectrum analyzer. Guess what happened?
Came up.
So, I'd say things like putting all their phones. If you're really going, we used to go and put phones into satchels and in a Faraday box.
Yeah.
So that's how serious it got for us.
Yes. Yes, I think that's where we're heading. We had a night up there recently, a superb clear night, great for the astrophotographers and the telescope people. But of course, that just brings along more phones, more stuff, more computers to drive all these telescopes. So radio astronomy is not compatible with all the optical people. So they've chosen for our next radio astronomy meeting, they've chosen a full moon night. So there'll be no optical astronomers around at all.
There is the other option of daytime.
Well, there'll be work during the day as well.
Yeah.
But
yeah.
Trouble is, people are setting up. They get there at midday, and they're setting up all afternoon. And the photography field is not that far from the radio astronomy shed, so it's a bit of a challenge. But yeah, so our dish should be back operating quite soon. All right.
Best wishes.
Well, this is why we have engineers. You mentioned engineers and physicists. I'm a physicist. I just do the theory and then point.
You raise a very interesting point. To go back to your very beginning of this talk, my take is that engineering physicists are actually much more powerful than physicists or engineers alone.
You need the bit in between.
Yeah, what I describe is you need the oil or the grease between the gears. My experience is we've got too siloed. People do one thing, not the other, and they don't understand the implications from one craft to the other craft.
Yes.
And if you're talking to your students at the moment, these sort of people are very, very rare. So, and it gives you a really interesting life because you do very, very different things.
Yes. Well, I think the day of the polymath has disappeared. The people who spanned across many fields, like Newton and Galileo and people like that. I think we've moved on from that, unfortunately.
I'll disagree, and I'll say it's an opportunity at the moment because the field is totally bare or nearly bare.
True. It's an opportunity.
Yeah, because you can.
The expression that I have heard is years ago, all the string and rubber band experiments have been done.
Yeah, it's what I call head and hands. Oh no, that I disagree with that. The nature of discovery is that people go out and do weird things that they can't get through national facilities. There's a whole theory about the constraint of how systems constrain innovation and initiative.
Yep.
So yeah,
that's so. There is a book early on in radio astronomy. There's a book called something about the occurrence of serendipity in radio astronomy. It's a very interesting book.
Yeah, is that the one written by written by Martin Howard?
Yeah.
Yep.
I think so. It's a very interesting very interesting book. I have it around here somewhere.
Yeah, I'm just searching for my copy and I can't find it, and I suspect I've lent it to somebody. But okay, just very simple experiments can be done that make large changes. I did an experiment in 1994 where I took a little bit of telescope time that wasn't allocated, took a partial image, and what I was doing required 12 hours, so I nicked 8 hours of imaging between two other observations. I went back a week later and I observed again, processed the data. It lay on my desk for 3 or 4 days. I finally got round to picking it up picking these two pieces of paper up, and just did a blink test for optical astronomers, but basically compared all the sources in the field. And one source had doubled its intensity in 1 week. And that told me, just from the very simple experiment and the speed of light, this had to be a point source of one light week across. So that's how simple an experiment, and that resulted in the discovery of a radio jet around a black hole in a binary system that was having an episode. So that's a simple experiment that people can do.
I think the key is, as you say, is serendipity. You've got to be in the right place at the right time.
I think also it's a prepared mind.
Yep.
And the willingness to read and think. Like this came out of my reading the Astronomer's Almanac, which might sound a bit weird, but I was looking at all the X-ray sources, and from the physics point of view, I went X-rays. Well, they boot electrons around. Why has nobody seen seen the X-ray sources from Ginga satellites in the 1970s, but why haven't we seen any of these sources? Because there must be some radio around them, and these are pretty violent events. And turns out it was a sampling problem. They just went out, looked at the source positions, and saw nothing. Well, that's because the source was off. It's that simple. Go out and look. Anyway, I'll get off my hobby horse.
Preston just joined us. Preston, do you have anything to share with us today?
No, not really. I was thinking about the meeting earlier today, and I got busy and forgot all about it. So I just all at once remembered and came in. So glad to hear what I can hear and learn what I can learn.
It's been recorded, so Rich will put it up on the YouTube channel. There we go, Cosmic Discovery.
Oh, that's great.
Search.
Thank you.
Cosmic Discovery. I'll just write that down.
It's a Harvester Press. This copy, published in Great Britain.
Yep.
I'll
have a look on Kindle. A lot of this stuff's on Kindle now. Not very much money.
Yeah, that's it's a fun book.
Yeah, 1981. Yeah, it's a fun book, but it does teach you a lot about how you go about doing discoveries.
Yeah.
And I'll say to you guys, every one of you is quite capable of going out and making a contribution to the field.
Yep. Once I've marked the exam, Duncan.
This is a much longer exam. It's a lifetime exam.
Yeah,
I understand, mate.
Need time. Yep. Okay. Anything else from anyone around in Australia or in the US? We covered some ground there. A lot of interesting things. I will. So we will be back in November, 4th Saturday in November, or 4th Friday for our American friends. I'll put together some ideas for the Radio Astronomy in Schools paper. If you've got anything that you think might be worth putting in there, just let me know and I'll include it. And then I'll continue contacting some some astronomy groups around Australia, and I thought it might extend to New Zealand as well. I think the time zones might work with the New Zealand contingent as well. Is it 2 hours different or something like that? I think we can probably.
About 2.5 hours from here, so 2 for you, and they went a couple of weeks earlier to summertime.
Yep. So I'll keep digging around there, but I think we might pull the plug at this stage unless anyone else got anything else. Thank you all for turning up, and great conversation. But as I say, we've covered a lot of ground. See you all in a month's time.
Thanks, Paul.
Thank you.
Okay. See you.
Thank you.
Yeah, thanks, Paul. And
Thank you.
good morning, everyone.